October 13th, 1944. The muddy plains of northern France stretched endlessly under a grey autumn sky, where Staff Sergeant Thomas Washington knelt beside a broken fuel pump that should have been simple to repair. The mechanical engineer from Detroit had been assigned to the 321st Engineer Combat Battalion, one of the few all-black units allowed to serve in combat roles during the global conflict. What the white officers observing him believed was that this college-educated Negro was wasting precious time with some ridiculous contraption made from scrap metal and wire, when they needed that fuel line operational within hours to support the advancing Allied forces. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. What those same officers would discover in the coming hours would fundamentally change their understanding of innovation, necessity, and the hidden brilliance that prejudice had blinded them to see, transforming not just their opinions, but potentially saving the lives of over 800 men whose tanks and vehicles depended on the fuel this engineer was desperately trying to deliver. Thomas Washington had grown up in the shadow of the Ford Motor Company's River Rouge plant, where his father worked the assembly line for 32 years without ever being promoted beyond the most basic positions reserved for Negro workers. The young man had earned his mechanical engineering degree from Tuskegee Institute in 1938, graduating summa cum laude with a thesis on innovative fuel delivery systems that his professors had praised as groundbreaking. When the war began, Thomas had initially been rejected for military service 3 times despite his qualifications, before finally being accepted into the segregated engineer corps, where his talents were systematically underutilized by commanders who viewed black soldiers as suitable only for manual labor and supply duties. The 321st Engineer Combat Battalion had been operating in France since D-Day +60, tasked with constructing and maintaining fuel depots that kept General George Patton's Third Army racing across the European countryside. Their mission was critical but unglamorous, ensuring that thousands of gallons of gasoline, diesel, and aviation fuel flowed continuously from Allied supply ships through a network of portable pipelines to forward operating bases where American armor and aircraft could refuel and continue their advance toward the German border. Lieutenant Colonel James Morrison, the battalion's commanding officer, had graduated from West Point in 1926 and spent 18 years in the Army Corps of Engineers building bridges, roads, and fortifications across the American South and Pacific territories. A tall man with prematurely gray hair and intense blue eyes, Morrison had requested assignment to an all-white engineering unit, but found himself commanding Negro soldiers due to what his superiors diplomatically termed personnel needs and operational requirements. He maintained strict military discipline and professional standards, but privately harbored deep reservations about the combat effectiveness and technical capabilities of the men under his command. Captain Robert Kellerman, Morrison's executive officer, had grown up on a wheat farm in Kansas before studying civil engineering at Kansas State University. Kellerman possessed genuine respect for technical competence, regardless of its source, but found himself constantly navigating the racial tensions that permeated military hierarchy during wartime. He had observed Thomas Washington's exceptional mechanical skills during their 6 months in France, noting how the staff sergeant could diagnose and repair complex equipment problems that stumped other technicians. But Kellerman's attempts to highlight Washington's abilities to higher command had been consistently dismissed or ignored. The fuel pump crisis had begun 3 days earlier when German artillery struck Fuel Depot Charlie, located 15 kilometers behind the advancing American lines. The depot supplied gasoline and diesel fuel to 2 full armored divisions and 3 infantry regiments, pumping approximately 50,000 gallons daily through a network of flexible pipelines that stretched across the Norman countryside. The artillery strike had been precisely targeted, suggesting German intelligence had identified the depot's strategic importance, and the resulting explosion had destroyed not only massive fuel storage tanks, but also the primary pumping station that pressurized the entire distribution network. Master Sergeant William Hayes, the battalion's senior maintenance non-commissioned officer, had worked as a mechanic in civilian life before the war, specializing in heavy industrial equipment for mining operations in West Virginia. Hayes commanded respect among both black and white soldiers for his practical knowledge and ability to keep complex machinery operational under field conditions. When the fuel pump explosion occurred, Hayes had immediately assembled a repair team and surveyed the damage, quickly determining that standard replacement parts would take weeks to acquire through normal military supply channels, time that advancing Allied forces simply did not possess. The destroyed pump system had been manufactured by the Worthington Corporation in Harrison, New Jersey, featuring a centrifugal design capable of moving 3,000 gallons per hour at pressures exceeding 200 pounds per square inch. The explosion had shattered the main impeller housing, destroyed all electrical controls, and twisted the drive shaft beyond any possibility of field repair. Army regulations specified that such complex equipment could only be replaced with identical components, requiring requisitions processed through Divisional Supply Headquarters, approved by ordnance specialists, and shipped from manufacturing facilities thousands of miles away in the United States. Thomas Washington had examined the wreckage immediately after the artillery strike, studying the twisted metal and burned components with the methodical approach his engineering professors had taught him at Tuskegee. While other soldiers focused on salvaging whatever usable parts remained, Washington began sketching designs in a small notebook, calculating pressures, flow rates, and mechanical specifications. His preliminary analysis suggested that a temporary replacement system could be constructed using salvaged materials and standard military equipment, but such a solution would require innovative engineering approaches that diverged significantly from established Army procedures and protocols. The fuel crisis had broader strategic implications beyond the immediate tactical situation facing the 321st Engineer Combat Battalion. General Patton's Third Army consumed approximately 800,000 gallons of gasoline daily as it raced across France toward the German frontier, with individual Sherman tank battalions requiring 15,000 gallons every 24 hours to maintain their operational tempo. The Normandy invasion had been meticulously planned around fuel logistics, with Allied planners calculating that adequate petroleum supplies represented the single most critical factor, determining the success or failure of the European campaign. The Red Ball Express, a convoy system operated primarily by black truck drivers, had been delivering supplies from Normandy beaches to forward units since August, covering 500 miles of French highways in continuous operations that often lasted 20 hours daily. These drivers transported not only fuel but also ammunition, food, medical supplies, and replacement equipment to combat units advancing faster than anyone had anticipated when the invasion was originally planned. The destruction of Fuel Depot. Charlie threatened to disrupt this carefully orchestrated supply chain, potentially forcing armored divisions to halt their advance, just as German resistance was beginning to weaken along the Siegfried Line. Technical Sergeant Eddie Coleman had served as Washington's assistant for 8 months, learning engineering principles while helping maintain the battalion's increasingly complex mechanical equipment. Coleman had grown up in rural Alabama, where formal education opportunities for black children rarely extended beyond 8th grade, but he possessed intuitive mechanical understanding that complemented Washington's theoretical knowledge. The partnership between the college-educated engineer and the self-taught mechanic had proven remarkably effective, solving equipment problems that frequently baffled other maintenance teams within their engineering battalion. On the morning following the artillery strike, Lieutenant Colonel Morrison convened a staff meeting to address the fuel depot situation and determine appropriate responses to the crisis. The meeting was held in a canvas field tent that served as battalion headquarters, with folding chairs arranged around a wooden table covered with maps, technical manuals, and damage assessment reports. Present were Morrison, Captain Kellerman, Master Sergeant Hayes, and the battalion's other senior officers, along with representatives from the Divisional Ordnance and Quartermaster Corps who had been dispatched to evaluate replacement requirements and delivery schedules. Major Richard Steinberg, the Divisional Ordnance Officer, had reviewed the damage reports and concluded that proper repairs would require approximately 6 weeks, assuming replacement parts could be located and shipped from manufacturing facilities in the continental United States. Steinberg, a Harvard-educated lawyer who had been commissioned into the Army Corps of Engineers in 1942, possessed extensive knowledge of military procurement regulations, but limited practical experience with field-expedient solutions to complex technical problems. "Gentlemen," Morrison began, spreading detailed photographs of the destroyed pump system across the table, "we have a significant logistical crisis that requires immediate attention and innovative solutions. Fuel Depot Charlie has been completely destroyed, cutting off gasoline and diesel supplies to approximately 12,000 men and 400 vehicles currently advancing toward the German positions along the Moselle River. Standard procurement procedures indicate we will not receive replacement equipment for approximately 6 weeks, which is completely unacceptable, given our current operational tempo and strategic objectives." Captain Kellerman studied the damage photographs, noting the complete destruction of the centrifugal pump housing and the twisted remains of the electrical control systems. "Sir," Kellerman said, "I've discussed this situation with our maintenance personnel, and Staff Sergeant Washington believes he might be able to construct a temporary replacement system using available materials and salvaged components. His approach would obviously not meet normal Army specifications, but it could potentially restore fuel flow within 72 hours if we can obtain approval to proceed with unconventional repair methods." Major Steinberg immediately objected to any deviation from established procurement procedures. "Captain, I understand the urgency of this situation, but we cannot simply ignore Army regulations and safety protocols. This fuel system operates at extremely high pressures and flow rates. Any improvised replacement could fail catastrophically, potentially causing explosions, fires, or other accidents that would be far worse than our current fuel shortage. The proper approach is to expedite delivery of certified replacement components through appropriate channels, even if that process requires additional time and resources." Morrison found himself torn between military regulations and operational necessity. His West Point training emphasized following proper procedures and maintaining clear chains of command. But 6 weeks without fuel supplies would effectively end the Allied advance and potentially allow German forces to regroup and strengthen their defensive positions. "Hayes," Morrison said, turning to the Master Sergeant, "what exactly does Washington propose to do? And more importantly, how confident are you in his technical abilities?" Master Sergeant Hayes had worked closely with Washington for months and had observed his exceptional problem-solving abilities in numerous situations where standard repair manuals provided no guidance. "Sir," Hayes replied, "Washington is the best mechanic and engineer in this battalion, possibly in this entire division. He's designed solutions to problems that stumped everyone else, including civilian contractors and factory representatives. His idea involves using salvaged pump components combined with standard Army generators and control equipment to create a temporary replacement system. It won't be pretty and it won't last forever, but he believes it will move the fuel we need until proper replacement parts arrive." Lieutenant Colonel Morrison studied the faces around the table, weighing military protocol against practical necessity. The strategic situation demanded immediate action, but authorizing unauthorized modifications to critical equipment carried significant risks to both mission success and his own military career. "Very well," Morrison decided. "Have Washington present his proposal this afternoon. I want detailed specifications, safety analysis, and realistic timelines. If his plan appears technically sound, we'll consider proceeding. But I want multiple senior engineers to review every aspect before we commit to implementation." That afternoon, Thomas Washington entered the headquarters tent carrying a folder filled with hand-drawn schematics, pressure calculations, and material specifications he had prepared during the previous night. The staff sergeant had worked by candlelight and flashlight, using engineering principles learned at Tuskegee to design a fuel pumping system that could be constructed entirely from materials available within their forward operating area. His proposal represented innovative thinking applied to desperate circumstances, combining theoretical knowledge with practical field expedients. Washington's presentation began with a careful analysis of the destroyed equipment and the specific requirements that any replacement system would need to meet. "Gentlemen," he said, unrolling his drawings across the conference table, The original Worthington pump was designed for permanent installation with redundant safety systems and precision manufacturing tolerances. Our situation requires a temporary solution that prioritizes immediate functionality over long-term reliability. I propose constructing a replacement system using 3 smaller pumps operating in parallel configuration, powered by standard Army generators and controlled through manual valve systems. The engineering concept was elegantly simple while remaining technically sophisticated. Washington had identified 3 salvageable pump units from destroyed vehicles and equipment scattered around the depot area. None of these individual pumps possessed sufficient capacity to replace the destroyed Worthington system, but operating them simultaneously through carefully designed manifold connections could theoretically achieve the required flow rates and pressures. The challenge lay in creating control systems and safety mechanisms using only materials available in their field supply inventory. Captain Kellerman studied Washington's calculations and found them remarkably thorough and professionally presented. The young engineer had considered factors including fluid dynamics, electrical load requirements, vibration dampening, and emergency shutdown procedures. His mathematical analysis demonstrated clear understanding of complex engineering principles, while his proposed construction methods showed practical knowledge of field conditions and available resources. Major Steinberg remained skeptical of any deviation from established procedures. "Sergeant Washington," he said, "your calculations appear mathematically sound, but this proposal involves significant modifications to safety-critical equipment. What happens if one of these pumps fails during operation? How do you propose to prevent pressure surges that could rupture fuel lines? And most importantly, who accepts responsibility if this improvised system causes accidents or equipment damage?" Washington had anticipated these questions and prepared detailed responses addressing each safety concern. "Sir," he replied, "the parallel pump configuration actually provides improved safety compared to the original single-unit design. If one pump fails, the other 2 can continue operating at reduced capacity until repairs are completed. I've designed pressure relief valves and flow restrictors that will prevent dangerous pressure surges, and manual controls allow operators to shut down individual pumps without affecting the entire system. The mathematical analysis indicates this configuration should operate reliably for at least 30 days, which provides sufficient time to obtain proper replacement equipment." The technical discussion continued for over an hour, as Washington answered detailed questions about his proposed design. His responses demonstrated not only solid engineering knowledge, but also practical understanding of field conditions and operational requirements. Several officers who had initially dismissed the proposal as improvised desperation began to recognize the sophisticated thinking underlying Washington's approach. Master Sergeant Hayes strongly endorsed Washington's plan, emphasizing the staff sergeant's track record of successful innovations under difficult circumstances. "Gentlemen," Hayes said, "I've worked with engineers and mechanics for 20 years, and Washington is among the most capable technical people I've ever encountered. He solved problems that stumped factory representatives and civilian contractors. If he says this system will work, I'm confident it will work." Lieutenant Colonel Morrison found himself impressed by Washington's presentation, but remained concerned about potential consequences if the improvised system failed catastrophically. Military careers had been destroyed by decisions that violated regulations, even when those decisions were tactically justified. "Sergeant Washington," Morrison said, "I appreciate your innovative thinking and technical expertise. However, I need time to consider the implications of your proposal and consult with higher headquarters before authorizing implementation. Continue developing your plans, but do not begin any actual construction until I provide explicit authorization." That evening, Morrison placed a secure telephone call to divisional headquarters, seeking guidance from Colonel Theodore Harrison, the Chief of Staff for Engineering Operations. Harrison was a career officer with 30 years of experience in military engineering, ranging from Panama Canal construction to Pacific Theater bridge-building operations. Morrison explained the fuel depot situation and Washington's proposed solution, emphasizing both the strategic necessity and the regulatory concerns involved in approving unconventional repair methods. Colonel Harrison's response was pragmatically direct. "Jim," he said, "we're fighting a war, not conducting peacetime engineering exercises. If this Negro sergeant can get fuel flowing to our advancing units, I don't care if he builds his pump system out of spare tank parts and baling wire. The Third Army is consuming fuel faster than we can deliver it, and any delay in supply operations puts American lives at risk. You have my authorization to proceed with whatever methods are necessary to restore fuel delivery capacity." Armed with explicit approval from divisional headquarters, Morrison authorized Washington to begin construction of his improvised pump system the following morning. The project would require cooperation from multiple units within the battalion, including mechanics, electricians, welders, and supply personnel who would need to locate and prepare the various components required for Washington's design. Morrison also assigned Captain Kellerman to oversee the project and ensure that proper safety protocols were maintained throughout the construction process. Thomas Washington began work at dawn on October 15th, assembling his construction team and surveying the available materials and equipment. The 3 pumps he planned to use had been salvaged from destroyed tank destroyers and self-propelled artillery pieces, each unit requiring significant refurbishment before installation. Technical Sergeant Coleman and 5 other mechanics were assigned to assist with pump rebuilding, while electricians worked on generator connections and control wiring under Washington's supervision. The salvaged pumps presented unique challenges because they had been designed for different applications, with varying specifications and operating characteristics. The first unit, recovered from a damaged M10 tank destroyer, was designed for hydraulic fluid circulation and operated at higher pressures than required for fuel transfer. The second pump, salvaged from a self-propelled howitzer, had been used for coolant circulation and featured different inlet and outlet configurations. The third pump came from a destroyed fuel truck and was closest to the required specifications, but had suffered significant damage during the artillery attack that destroyed the original depot. Washington spent hours studying manufacturers' data plates and technical specifications for each pump unit, calculating how to modify their operating characteristics to work effectively in parallel configuration. This process required not only engineering knowledge, but also practical understanding of metallurgy, fluid dynamics, and electrical systems. He designed custom manifold connections that would equalize pressure and flow between the 3 units, while providing isolation valves for individual pump maintenance. The manifold construction required welding skills that exceeded the capabilities of standard Army field maintenance procedures. Washington had learned advanced welding techniques during summer employment at the Ford River Rouge plant, where he had worked alongside skilled tradesmen who taught him precision metalworking methods. Using a borrowed welding generator and salvaged steel pipe, Washington fabricated manifold sections that connected the 3 pumps through carefully calculated angles and flow restrictions. Private First Class Marcus Johnson, a welder from Birmingham, Alabama, assisted Washington with the more complex fabrication work. Johnson had learned welding in civilian shipyards before military service and possessed exceptional skills in working with damaged or non-standard materials. The partnership between Washington's engineering knowledge and Johnson's welding expertise produced manifold assemblies that exceeded the quality standards typically achieved in field repair operations. As construction progressed, word of Washington's project spread throughout the battalion and attracted attention from officers and enlisted men who were curious about the improvised pump system. Some observers expressed admiration for Washington's innovative approach and technical skills, while others remained skeptical about the wisdom of replacing precision-manufactured equipment with field-expedient alternatives. The project became a focal point for broader discussions about military protocol, engineering innovation, and racial attitudes within the wartime Army. Second Lieutenant David Patterson, a recent graduate of Georgia Institute of Technology, who served as the battalion's assistant engineering officer, initially dismissed Washington's project as dangerous improvisation that violated fundamental engineering principles. Patterson had studied pump design theory during his college coursework and believed that any deviation from manufacturer specifications would inevitably lead to equipment failure and potential safety hazards. "This is exactly the kind of thinking that gets people hurt," Patterson complained to Captain Kellerman. "We have established procedures and safety regulations for good reasons. Allowing an enlisted man to modify critical equipment based on improvised calculations is asking for trouble. When this contraption fails, who's going to explain to families why their sons were hurt or worse because we ignored proper engineering practices?" Captain Kellerman found himself defending Washington's capabilities while acknowledging Patterson's legitimate safety concerns. "David," Kellerman replied, "I understand your reservations and safety is obviously our primary concern, but Washington's engineering credentials are impeccable. His calculations are thoroughly documented, and we have explicit authorization from divisional headquarters to proceed. This isn't casual improvisation, it's innovative engineering applied to desperate circumstances. The alternative is leaving our advancing units without fuel for 6 weeks, which presents far greater risks than any theoretical problems with Washington's design." The technical challenges of pump synchronization required Washington to design control systems that could manage 3 different units operating simultaneously while maintaining consistent pressure and flow rates. Standard military equipment included pressure gauges, flow meters, and electrical controls that could be adapted for this purpose, but Washington had to create custom wiring configurations and mechanical linkages that would allow operators to monitor and adjust the system effectively. Sergeant First Class Robert Martinez, an electrician from Los Angeles who had worked on aircraft assembly lines before military service, collaborated with Washington on the electrical control systems. Martinez possessed excellent understanding of generator operations and power distribution, skills that proved essential for creating reliable electrical connections between the pumps, generators, and control equipment. The electrical work required careful attention to voltage regulations, circuit protection, and emergency shutdown procedures. The generator requirements presented another complex challenge because the 3 pumps had different electrical specifications and power consumption characteristics. Washington calculated that total power requirements would exceed the capacity of any single Army generator available in their supply inventory, requiring a dual generator configuration with load distribution and synchronization controls. This arrangement was technically feasible, but required sophisticated electrical work that pushed the limits of field repair capabilities. Major Steinberg continued to express reservations about the project, particularly regarding liability and accountability issues if the improvised system caused accidents or equipment damage. "I understand the operational necessity," he told Morrison, "but I remain concerned about the precedent this sets regarding regulatory compliance and safety protocols. If we authorize one engineer to ignore established procedures based on personal judgment, how do we maintain discipline and consistency across other engineering operations?" Morrison balanced these concerns against strategic necessity and the explicit authorization he had received from divisional headquarters. "Major," he replied, "I share your concerns about regulatory compliance, but we're operating under wartime conditions that require flexibility and innovation. Colonel Harrison has explicitly authorized this project, and Washington's technical credentials are beyond question. Our responsibility is ensuring that proper safety measures are implemented and documented, not preventing innovative solutions to critical problems." Construction of the improvised pump system required 4 days of intensive work by a team that eventually included 12 mechanics, electricians, and welders working under Washington's direct supervision. The project consumed significant quantities of salvaged materials, including steel pipe, electrical wire, gaskets, fittings, and other components that had to be located throughout their forward supply area. Washington maintained detailed documentation of all modifications, safety measures, and operational procedures, creating a comprehensive technical manual that could guide future operations and maintenance. On October 19th, the improvised pump system was ready for initial testing under controlled conditions. Washington had insisted on extensive safety preparations, including fire suppression equipment, emergency shutdown procedures, and personnel protection measures that exceeded standard field operations protocols. The test would involve pumping water through the system at gradually increasing pressures and flow rates, while monitoring all operating parameters and safety systems. Lieutenant Colonel Morrison, Captain Kellerman, Major Steinberg, and several other officers gathered to observe the initial test, along with enlisted personnel who had participated in the construction project. The atmosphere was tense with anticipation and anxiety as Washington conducted final inspections and prepared to start the generators that would power his improvised pump system. "Gentlemen," Washington announced, "I'm going to start the generators and begin initial pressure testing at 25% capacity. All personnel should remain behind the designated safety line until we verify that all systems are operating normally. Technical Sergeant Coleman will monitor pressure gauges while I observe the pump operations and electrical systems." The first generator started smoothly, followed by the second unit, creating a steady mechanical rhythm that filled the air around the test area. Washington gradually increased power to the first pump, watching pressure gauges and listening carefully to mechanical sounds that would indicate any problems with bearings, seals, or other critical components. The pump began moving water through the test line at progressively higher flow rates, while maintaining steady pressure readings. As the second and third pumps came online, Washington carefully balanced their operations to achieve synchronized flow rates and pressure levels. The manifold system functioned exactly as his calculations had predicted, equalizing pressure between the three units while providing the combined flow capacity required for fuel depot operations. Initial test results exceeded expectations, with the improvised system achieving 93% of the original equipment's rated capacity while maintaining excellent stability and control characteristics. Major Steinberg observed the testing process with grudging admiration for Washington's technical achievement, even while maintaining reservations about the long-term reliability and safety of improvised equipment. "I have to admit," he said to Morrison, "this appears to be working better than I expected. Washington clearly knows what he's doing from an engineering standpoint. My concerns remain focused on long-term reliability and maintenance requirements, but for temporary operations, this system seems adequate." The successful water testing led to authorization for fuel operations, beginning with diesel transfer at reduced capacity to verify that the system could handle petroleum products safely and effectively. Washington had designed special filtration and vapor control systems to address the unique challenges of fuel handling, including fire suppression equipment and emergency procedures specifically adapted for petroleum operations. Captain Kellerman coordinated with quartermaster personnel to ensure adequate safety measures and fire protection during fuel operations. The first diesel transfer test involved pumping 500 gallons through the system, while monitoring for leaks, pressure variations, or other operational problems. Washington personally supervised every aspect of the operation, making minor adjustments to flow controls and pressure settings as needed to optimize system performance. The diesel test proceeded flawlessly, with the improvised pump system maintaining steady flow rates and pressure levels throughout the operation. Washington's pressure relief valves and safety controls functioned exactly as designed, providing multiple layers of protection against equipment failure or operational errors. The test demonstrated that his engineering calculations had been accurate and that the improvised system could safely handle the petroleum products required for military operations. Following successful diesel testing, Washington received authorization to begin full-scale gasoline operations, supporting the fuel requirements of advancing Allied units. The transition to gasoline presented additional safety challenges because of increased fire and explosion risks, requiring enhanced vapor control and fire suppression measures. Washington had prepared detailed operating procedures and safety protocols specifically for gasoline operations, drawing on his engineering education and practical experience with petroleum handling systems. The first full-capacity gasoline transfer began on October 21st, with Washington's improvised pump system delivering 3,000 gallons per hour to fuel trucks that would transport gasoline to forward operating bases. The operation required continuous monitoring and frequent adjustments to maintain optimal flow rates while ensuring safety systems remained fully operational. Washington and his maintenance team worked in rotating shifts to provide 24-hour coverage of the pump operations. Technical Sergeant Coleman proved invaluable during extended operations, having learned Washington's procedures and safety protocols thoroughly enough to supervise pump operations during night shifts. Coleman's mechanical intuition and attention to detail ensured that minor problems were identified and corrected before they could develop into serious operational issues. The partnership between Washington's engineering expertise and Coleman's practical skills created a maintenance capability that exceeded the performance of many standard Army engineer units. As fuel operations continued successfully for several days, attitudes within the battalion began shifting from skepticism to admiration for Washington's technical achievement. Officers and enlisted men who had initially dismissed his improvised system as dangerous experimentation now recognized the sophisticated engineering thinking that had made the project successful. Washington's innovation had not only solved a critical operational problem, but had also demonstrated capabilities that challenged prevailing assumptions about black technical personnel. Second Lieutenant Patterson underwent the most dramatic change in attitude, evolving from harsh critic to enthusiastic supporter of Washington's approach. Patterson had initially viewed the project through the lens of textbook engineering theory, but observing the successful implementation of innovative solutions under field conditions taught him valuable lessons about practical application of engineering principles. "I owe you an apology," Patterson said to Washington after a week of successful fuel operations. "I was wrong to dismiss your approach based purely on theoretical objections. What you've accomplished here represents excellent engineering work under incredibly difficult circumstances. I've learned more about practical problem solving from watching your project than I did during 4 years of college coursework." The strategic impact of Washington's pump system extended far beyond the immediate fuel supply situation. The 321st Engineer Combat Battalion resumed full-capacity fuel operations 6 weeks earlier than would have been possible using standard procurement procedures, enabling Allied armored units to maintain their rapid advance toward German defensive positions along the Rhine River. The restored fuel flow supported operations involving over 800 vehicles and 12,000 personnel, directly contributing to tactical successes that shortened the duration of the European campaign. General Patton's Third Army consumed the fuel delivered through Washington's system during crucial operations that led to the breakthrough at Metz and the subsequent crossing of the Rhine River. Military historians would later identify fuel logistics as one of the critical factors that enabled Allied forces to maintain offensive momentum during the autumn of 1944, preventing German forces from establishing strong defensive positions that could have prolonged the conflict for months or years. Master Sergeant Hayes submitted detailed reports to divisional headquarters, highlighting Washington's exceptional technical contribution and recommending him for promotion and recognition. Hayes emphasized that Washington's innovation had saved weeks of operational delay, while demonstrating engineering capabilities that exceeded those of many commissioned officers. The reports included testimonials from multiple officers who had observed Washington's work and been impressed by his technical competence and professional dedication. Lieutenant Colonel Morrison added his own endorsement to Washington's commendation reports, noting that the staff sergeant's innovation had demonstrated exactly the kind of creative problem-solving that the Army needed to encourage among its technical personnel. Morrison's report specifically recommended that Washington be considered for officer candidate school, where his engineering education and proven leadership abilities could be utilized more effectively than in his current enlisted status. The recommendation for officer candidate school represented a significant departure from normal Army practice regarding black enlisted personnel during 1944. Very few black soldiers were accepted for officer training during World War II, and most of those who achieved officer status served in segregated units with limited advancement opportunities. Morrison's strong endorsement carried considerable weight because of his West Point credentials and distinguished service record. Captain Kellerman prepared a detailed technical report documenting Washington's pump system design and construction methods, believing that the innovative approach could be valuable for other engineer units facing similar equipment failures and supply shortages. Kellerman's report included complete engineering drawings, material specifications, and operating procedures that would allow other units to replicate Washington's success under comparable circumstances. The technical documentation process revealed the sophisticated nature of Washington's engineering work, which had been accomplished without computer assistance, specialized design software, or access to manufacturers' technical libraries. Working with only basic mathematical tools and field reference materials, Washington had created a complex mechanical system that met demanding performance requirements while maintaining excellent safety standards. His achievement demonstrated exceptional engineering capability applied under the most challenging possible circumstances. Major Steinberg gradually acknowledged that Washington's project had succeeded beyond all reasonable expectations, achieving performance levels that approached those of factory-manufactured equipment, while providing reliability that enabled weeks of continuous operation. Steinberg's final report praised Washington's technical competence and innovative thinking, while recommending that similar field expedient solutions be considered for other equipment failures and supply shortages. The psychological impact of Washington's success extended throughout the 321st Engineer Combat Battalion and beyond to other units that heard about the project through informal military communication networks. Black soldiers in particular took pride in Washington's achievement, which demonstrated that exceptional technical competence could overcome racial prejudice and earn recognition from white officers who had previously dismissed black capabilities. The success also influenced white soldiers and officers who witnessed Washington's work, challenging their assumptions about black technical abilities and professional competence. Many individuals who had never seriously considered black soldiers as equals found themselves forced to acknowledge Washington's exceptional achievement and reconsider their racial attitudes. The transformation was gradual and incomplete, but it represented measurable progress toward greater racial understanding within military ranks. Corporal James Mitchell, a mechanic from Mississippi, who had initially refused to work under Washington's supervision because of racial prejudice, became one of the project's most enthusiastic supporters after observing the staff sergeant's technical expertise and leadership abilities. Mitchell later requested transfer to Washington's maintenance section, where he learned advanced mechanical procedures that enhanced his own professional capabilities. "I was wrong about everything," Mitchell admitted to his squad mates. "Washington is the best engineer and mechanic I've ever seen, and I've learned more working with him than in all my previous mechanical experience combined. Anyone who judges people based on race instead of ability is missing out on learning from exceptional individuals who can teach valuable skills and knowledge." The fuel pump project became a catalyst for broader discussions about military efficiency, personnel utilization, and the waste of human resources caused by racial segregation and discrimination. Progressive officers began questioning whether the Army could afford to continue underutilizing talented black soldiers when their skills were desperately needed for complex technical operations. The conversations remained private and limited in scope, but they represented early recognition of issues that would eventually lead to military integration. Washington's success also attracted attention from civilian engineers and technical personnel, who visited the fuel depot during routine inspections and supply operations. Several civilian contractors expressed amazement at the sophisticated engineering work that had been accomplished using only field-available materials and basic tools. Their reports to military contractors and government agencies helped spread awareness of exceptional technical talent within black military units. The temporary pump system continued operating successfully for 7 weeks until factory-manufactured replacement equipment finally arrived from the United States. During that period, Washington's improvised system delivered over 2 million gallons of fuel to Allied units without experiencing major mechanical failures or safety incidents. The performance record exceeded that of many permanently installed systems operating under controlled conditions with full maintenance support. When the permanent replacement equipment was finally installed, Washington supervised the transition process and conducted training for personnel who would operate the new system. His professionalism and technical expertise during the equipment changeover impressed civilian contractors and military engineers who had come to oversee the installation. Several individuals commented that Washington's understanding of pump operations and fuel systems exceeded that of many factory-trained technicians. The removal of Washington's temporary system provided an opportunity to examine the engineering work that had made it successful. Inspection revealed that his welding, fabrication, and electrical work met or exceeded military quality standards, despite being performed under field conditions with improvised tools and materials. The examination confirmed that Washington's engineering calculations had been accurate and that his safety measures had been properly designed and implemented. Components from Washington's improvised system were saved and eventually shipped to Army engineer training facilities, where they were used to teach advanced field repair techniques to other technical personnel. The system became a case study in innovative engineering solutions and was featured in training manuals used to educate Army engineers about creative problem-solving under field conditions. Thomas Washington received promotion to Technical Sergeant in November 1944, along with a Bronze Star Medal recognizing his exceptional technical contribution to Allied operations in France. The promotion represented the highest enlisted rank available to black soldiers in most Army units during World War II, though Washington's qualifications clearly warranted officer status that remained unavailable due to racial restrictions. The Bronze Star citation specifically mentioned Washington's innovation, technical expertise, and leadership during the fuel depot crisis, noting that his engineering solution had enabled continued operations by over 800 vehicles and 12,000 personnel. The award represented official recognition of exceptional individual achievement that had directly contributed to Allied military success in the European theater. Washington's application for Officer Candidate School was approved in December 1944, making him one of fewer than 50 black soldiers accepted for officer training during that period. The approval represented a significant achievement, not only for Washington personally, but also as recognition that exceptional individual merit could occasionally overcome institutional racial barriers within the wartime military establishment. The Officer Candidate School experience provided Washington with formal military leadership training to complement his technical education and practical experience. He graduated second in his class of 64 candidates, earning a commission as second lieutenant in the Army Corps of Engineers. The achievement made him one of the few black commissioned engineers in the entire European theater of operations. Lieutenant Washington's first assignment as a commissioned officer involved supervising engineer operations during the Allied advance into Germany, where his technical expertise and leadership abilities were utilized more effectively than had been possible during his enlisted service. He participated in bridge construction, road repair, and fortification projects that supported the final Allied offensive that ended the European War in May 1945. The post-war period brought new challenges and opportunities for Washington, who remained in military service during the transition to peacetime operations. His wartime achievements had established his reputation as an exceptional engineer and leader. But racial integration of the military would not occur until several years later, under President Truman's executive order in 1948. Washington eventually left military service in 1946 and returned to civilian life, where he found employment with Ford Motor Company as a design engineer working on advanced automotive systems. His military experience and proven ability to solve complex technical problems under pressure made him valuable to civilian employers who were beginning to recognize the capabilities of black technical personnel. The Ford position provided Washington with opportunities to apply his engineering expertise to peacetime challenges, including the development of improved fuel systems, hydraulic controls, and manufacturing processes. His innovative approaches and practical problem-solving abilities led to numerous patents and technical publications that established him as a recognized expert in automotive engineering. In 1952, Washington founded his own engineering consulting firm, specializing in industrial equipment design and manufacturing process improvement. The company grew rapidly as clients recognized the exceptional quality of his technical work and his ability to solve problems that other engineers had been unable to address. His wartime experience with field expedient solutions proved valuable for civilian applications involving emergency repairs and equipment modifications. Washington's success in civilian engineering led to numerous speaking engagements and professional recognition, including election to the American Society of Mechanical Engineers and appointment to several government advisory committees on technical standards and manufacturing practices. He used these opportunities to advocate for expanded educational and employment opportunities for black engineers and technical personnel. The engineering consulting firm eventually employed over 40 engineers and technicians, becoming one of the most successful black-owned technical businesses in the Midwest during the 1950s and 60s. Washington's commitment to professional excellence and innovation created opportunities for other black engineers, while demonstrating that technical competence transcended racial boundaries in competitive business environments. Thomas Washington retired from active engineering practice in 1975, but remained involved in education and mentoring activities that encouraged young black students to pursue technical careers. He established scholarship programs at several historically black universities and served on engineering school advisory boards that promoted diversity and excellence in technical education. The fuel pump innovation that had saved a battalion in France became a defining moment not only in Washington's personal career, but also in the broader narrative of black contributions to American military and technical achievements. His story demonstrated that exceptional individual capability could overcome institutional prejudice when circumstances demanded practical solutions over social conventions. The 321st Engineer Combat Battalion was deactivated in 1946 as part of post-war military reorganization, but the unit's achievement in maintaining fuel operations during critical phases of the European campaign was officially recognized in military histories and commendation records. Washington's innovation was specifically mentioned in several historical accounts as an example of effective technical leadership under combat conditions. Lieutenant Colonel Morrison continued his military career after the war, eventually achieving the rank of full colonel before retirement in 1958. In post-war interviews and memoirs, Morrison consistently credited Washington's engineering expertise as one of the most impressive examples of technical problem-solving he had witnessed during 30 years of military service. Morrison became a strong advocate for military integration and equal opportunity in technical fields. Captain Kellerman left military service in 1946 and pursued a career in civilian construction management, where his experience working with diverse technical teams proved valuable in increasingly integrated business environments. Kellerman maintained contact with Washington throughout the post-war period and frequently cited the fuel pump project as an example of how innovative thinking and professional competence could overcome seemingly impossible technical challenges. Master Sergeant Hayes retired from military service in 1951 after completing 30 years of active duty. In retirement, Hayes often spoke at veterans organizations and military schools about leadership and technical innovation, consistently highlighting Washington's fuel pump project as the most impressive example of field engineering he had witnessed during his military career. Technical Sergeant Coleman used his military engineering experience to establish a successful mechanical repair business in Detroit, specializing in industrial equipment maintenance and modification. Coleman credited his association with Washington as the foundation for his technical knowledge and business success, noting that working with an exceptional engineer had taught him problem-solving approaches that proved valuable throughout his civilian career. The broader historical significance of Washington's achievement extended beyond individual recognition to its demonstration of hidden capabilities within segregated military units. Military historians have noted that the fuel pump project represented one of many examples of black technical excellence that was systematically underutilized due to racial prejudice and institutional discrimination during World War II. Recent scholarship has examined how racial segregation and discrimination limited military effectiveness by preventing full utilization of available human resources. Washington's story illustrates how exceptional individual achievement could occasionally overcome institutional barriers, but also highlights the waste of human potential that resulted from systematic exclusion of capable personnel from appropriate positions and opportunities. The engineering principles that Washington applied to solve the fuel pump crisis remained relevant for decades after World War II, as military and civilian engineers continued to face situations requiring innovative solutions, using limited resources under challenging conditions. His approach of combining theoretical knowledge with practical adaptation became a model for field engineering operations in subsequent conflicts and civilian emergency situations. Educational institutions have used Washington's story to illustrate the importance of creative problem-solving and the application of engineering principles under real-world constraints. His achievement demonstrates how fundamental technical knowledge can be adapted to address unexpected challenges when combined with practical experience and innovative thinking. The fuel pump project has been featured in engineering curricula as an example of successful field expedient solutions and the importance of maintaining safety standards while pursuing innovative approaches to technical problems. Washington's documentation and safety procedures have been studied as examples of professional engineering practice under challenging circumstances. Modern military engineer training includes case studies of Washington's fuel pump innovation as an example of the creative problem-solving abilities that contemporary engineers must develop to address complex technical challenges under field conditions. The project demonstrates the importance of combining theoretical knowledge with practical experience and innovative thinking. The story of Thomas Washington and his fuel pump innovation has been preserved in military museums and historical archives as an important example of Black contributions to Allied victory in World War II. These exhibits help educate current and future generations about the hidden history of Black technical excellence and its significance for military and civilian achievements. Veterans organizations and historical societies have recognized Washington's achievement through various commemorative activities and educational programs that highlight the often overlooked contributions of Black soldiers and technical personnel during World War II. These recognition efforts help correct historical narratives that previously minimized or ignored Black achievements. The engineering consulting firm that Washington founded continued operations long after his retirement, maintaining his commitment to technical excellence and professional development opportunities for Black engineers. The company's success demonstrated the long-term impact of his World War II achievements in establishing credibility and professional recognition that extended throughout his civilian career. Thomas Washington passed away in 1998 at the age of 78, leaving behind a legacy of technical innovation, professional achievement, and commitment to expanding opportunities for future generations of Black engineers and scientists. His funeral was attended by hundreds of colleagues, former military associates, and individuals whose careers had been influenced by his mentoring and example. The Bronze Star Medal and other military decorations that Washington received during World War II were donated to the Tuskegee Institute Museum, where they are displayed alongside exhibits highlighting the achievements of Black military personnel and the contributions of historically Black universities to American technical and scientific progress. Contemporary engineering students continue to study Washington's fuel pump innovation as an example of successful technical problem-solving and the importance of maintaining safety standards while pursuing creative solutions under challenging circumstances. His achievement remains relevant for current engineers who must address complex technical challenges using limited resources and innovative thinking. The transformation in racial attitudes that Washington's achievement helped inspire within the 321st Engineer Combat Battalion represented early progress toward the military integration that would occur several years later under President Truman's executive order. While individual achievements could not immediately overcome institutional discrimination, they provided examples that challenged prevailing assumptions and prepared the foundation for subsequent policy changes. Military historians have noted that Washington's story exemplifies the broader pattern of Black technical excellence that existed despite systemic discrimination during World War II. His achievement, along with those of many other Black soldiers, scientists, and technical personnel, helped establish the foundation for post-war civil rights advances and expanding opportunities in technical fields. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.